8 planets, billions of kilometers apart, all orbiting in nearly the same flat plane, as if someone arranged them on a cosmic dinner plate. That is not a coincidence. It is a record of the most violent period in the solar system's history. And the exceptions, the things that do not orbit in the plane, tell an even more disturbing story about what happened in the early solar system. The answer starts 4.6 billion years ago with a molecular cloud, an enormous region of gas and dust drifting through the Milky Way. Something disturbed it. The leading candidate is a nearby supernova whose shockwave compressed the cloud enough to trigger gravitational collapse. The cloud began to fall inward under its own gravity. Here is where the physics becomes decisive. The cloud was not perfectly still. It had a slight rotation, a tiny net angular momentum from the random motions of its particles. As the cloud collapsed and its material fell inward, that rotation had to be conserved. This is the same principle that makes a figure skater spin faster when they pull their arms in. Conservation of angular momentum. As the cloud shrank from light years across to something the size of the solar system, that slight rotation amplified dramatically. The result is a protoplanetary disk. Material falling inward cannot simply pile up at the center, because particles approaching from different directions collide, and their motion perpendicular to the rotation axis cancels out, while their rotation in the plane of the disk reinforces. What survives is a flat, rotating disk of gas and dust surrounding the forming sun at the center. The disk is the path of least resistance, the equilibrium configuration where angular momentum is conserved and orbital dynamics are stable. Within that disk, dust grains collide and stick together. Pebbles form. Pebbles collide and form boulders. Boulders accumulate into planetesimals, bodies perhaps kilometers across. Planetesimals gravitationally attract more material and grow into protoplanets. All of this accretion happens within the disk, so the resulting planets inherit the disk's flat geometry. The ecliptic plane, the plane of Earth's orbit, is a direct fossil of that original protoplanetary disk. The numbers confirm it. Mercury's orbit is inclined about 7 degrees to the ecliptic. Venus is about 3.4 degrees. Mars is about 1.9 degrees. Jupiter is about 1.3 degrees. Saturn about 2.5 degrees. The outer planets are all within a few degrees of the same plane. For objects that formed in a disk, this alignment is exactly what the physics predicts. Now the exceptions. Pluto orbits at an inclination of about 17 degrees to the ecliptic. Many Kuiper Belt objects have high inclinations. Comets from the Oort cloud arrive from all directions, with random orbital inclinations. These are not failures of the disk model. They are evidence of what happened after the planets formed. The late heavy bombardment, a period of intense impact activity in the inner solar system roughly 3.9 to 4.1 billion years ago, is associated with gravitational instability among the giant planets. Models including the NICE model and the Grand Tack hypothesis propose that Jupiter and Saturn migrated in their orbits during the early solar system. Jupiter may have moved inward as far as 1.5 astronomical units before being pulled back out by Saturn. This migration scattered small bodies into high inclination, eccentric orbits, populating the Oort cloud and the scattered disk, producing the comets and high-inclination Kuiper Belt objects we see today. Pluto's orbit is in a 3-2 resonance with Neptune. For every 2 orbits of Neptune, Pluto completes 3. This resonance is a gravitational parking spot created by Neptune's outward migration during the early solar system. Pluto and other Plutinos were swept into this resonance as Neptune moved outward, explaining both their inclinations and their orbital periods. The flat plane of the planets is the original blueprint. Everything that deviates from it is the signature of the chaos that followed. Follow for more solar system formation science explained clearly. And tell me, knowing the solar system's flat plane is a fossil of a collapsing molecular cloud, does it surprise you that the planets ended up as organized as they did?